we are looking at 3 systems of inequalities, and we are going to be graphing with them and working with them. So first things first, a solution to a system of inequalities is a set of ordered pairs that satisfies all of the inequalities. So if I pick an ordered pair, it has to make a true statement in both inequalities, and then we know it's a solution. When you're graphing them, the solution is where the shading overlaps. So we're going to have multiple graphs on one line. Okay, so we're going to jump in here to number 1. And the first thing I need to do is I'm going to make them y equals mx plus b, but you could graph using x and y intercepts as well. Now, when I solve this for y, I'm going to subtract the x and bring it over there. And then I'm going to divide by -1. And what happens when we divide by a negative? Flip the inequality sign. So we are going to have y is now less than a positive 1x and then -1. So check your signs. We need to think about our slope, which is 1/1, our y-intercept, which is -1, and it's an inequality. So should this be a dashed or a solid line? Dashed line, because it's not equal to. So starting at the y-intercept on the y-axis at -1, a positive 1 and right 1 up and over, and you told me a dashed line. So we want accurate lines, so I've got some extra points. I'm going to come in and make it dashed, and then we need to determine how to shade it. So here's my line. I'm looking at my final cleaned up y equals mx plus b, and it says y is less than. So that means I'm going to shade going down. Okay. Now, if you want to shade everything, go ahead, shade the whole line. Make sure you're extending your lines to fill your graph so we can see where this is going. I'm going to put little arrows and know that I need to shade down here. Okay. You want to use different highlighters, different colored pencils. That's fine. I'm going to go ahead and start this next one. I'm going to subtract the x and get 4y is greater than -x plus 20. I'm putting it in order there. I'm going to divide every piece by 4. And I get y is greater. Now, this is where we have issues. What's the number in front of the x? Isn't it like a -1 there? Dividing by 4 is not the same as multiplying by 4, right? So it's not 4x, guys. It's -1/4 and then x. So think about that being a fraction 1/4. Keep the negative sign. Okay, and then 20/4 is +5. I didn't multiply or divide by negative, so I kept my inequality as is. The slope is -1/4 and the y-intercept is +5. So start on the y-axis at 5. I'm going to go down 1, but then I have to go right 4. You only get one negative. If you want to go up 1, then go left 4. This one is also a dashed line. And then we need to determine where to shade. And this one says that y is greater, so I'm going to shade going up. Why am I shading up and down? Because I'm using the y-axis, I'm shading going up. You want to use a test point, that's fine. My final shaded region is actually right in this corner. So it might help if you were shading. I could see that I shaded this green down and the red up, and that's my final shaded region. What's that mean? If I pick something in this yellow region and it keeps going, it would work and be a solution to both inequalities, give me a true statement. If I pick something down here, it would only work in my green inequality. If I pick something up here, it only work in my red. If I pick something out here, it won't work at all. So a solution is something that will make every inequality true. There are infinite solutions because we can pick anything in the shaded region, but they can't be on the dashed lines. All right, jump over to number 2. And the first thing we need to do is solve for y equals mx plus b, unless you're using x and y intercepts. So we've subtracted the 7x. I'm going to come in and divide each piece by 3. I would prefer leaving slope always as a reduced fraction, not a mixed number, not a decimal, but I'm going to clean up my y-intercept and get a +6. So again, if you don't multiply or divide by negative, don't flip your sign. All right, slope, -7/3, y-intercept, +6. So put your point here. on the y-axis, down 7, and then right 3. If your slope is negative, your line should be dropping. So double check that. Dash your solid line on this one. Solid line. And then take a second and determine where to shade. Our inequality said y is less than. So if I'm less than, I'm going underneath the line, going down the y-axis, or again, use a test point. Okay, this one. First thing I'm going to do is subtract 2x. So I'm left with negative 3y is less than or equal to negative 2x plus 9. And then I'm going to come in and divide each piece by negative 3. So slow it down. Flip your inequality. Double check your signs to be 2/3 x. Divide out the negative, and that's what we get. Slope is 2/3. Y-intercept, negative 3. Okay, plot your point on the y-axis at negative 3. Rise 2, run 3. Sometimes you'll get a nice intersection, but sometimes in inequalities we don't. Dash your solid on this one. Solid because it can be equal. Take a second, determine where you're shading. Remember, we flipped it. Always go back to your simplified y equals mx plus b. Y is greater. So final shaded region along the lines, and then everything here. All right, the top inequality, I'm going to subtract 4x. So I'm left with the negative 5y greater than negative 4x minus 5. Divide each piece by a negative, so a lot of inequality flipping. Y is less than a positive 4/5 x plus 1. I have a habit of boxing this, 1, so it's easy for my teacher to find my final inequality, and 2, it draws my attention to it so I don't look at the wrong inequality. All right, starting point at 1, rise 4, run 5, so positive and positive. You could go negative 4 and then negative 5. Dash your solid line on this one. Less than, so it would just be dashed. And then take a second and you determine where to shade, and we'll see if we agree. Y is less than, we'd be shading going down. So again, if you want to, go ahead and shade that in lightly. It's just really important that I can see your final shading. What about this second inequality there? I can't solve for y. What's going on with that? Show me with your arms. I got one person showing me. What kind of line is it? Okay, it's your vertical line. Yep. It cuts through the x-axis at -1, and it is solid. Just so we remember this, what's the slope of this vertical line? Undefined. It is undefined. What is the slope of a horizontal line? If your line was horizontal, the slope is 0. And if just for kicks, let's say I had an XY chart here. This is X, this is Y, and this is my graph. What would be the equation if my line was horizontal? So we just did our vertical one, but this was my line. It was a horizontal line. What would be the equation? You said it has a slope of 0. How would you write the equation of this line? Well, I'll remind you, it cuts through the y-axis at 5. So wouldn't this just be simply y equals 5? Okay. So if it's just x, it's going to be that vertical line. The slope is undefined. But if you see a y equals or y is greater than, it's going to be the one that cuts through the y-axis. Now, I still need to shade this. I went off on a tangent, I know. X is less than or equal to 1 would go to the left. And then the final shaded region would be this little corner down here. But it does go forever. I mean, this graph keeps going. So there you go. So I'm going to say it one more time. The solution, all the solutions are in the shaded region. They would make both of these items a true statement. So if we flip it over to the back, So in this problem, it's asking which points are solutions to the system of inequalities given below. Check all that apply. So this is a lot like what we did before. We want to plug it in and see if it's a true statement. Now notice that this says greater than, so it cannot be equal. So I'm expecting a little work. I'm going to take the point 1, 1 over here, and I'm going to show my work, and I'm going to just plug it in. So even though I can just use my calculator, I'm going to at least write this down. And I'm getting that -5 is greater than -48. And that's true because they're negative numbers, right? So I agree with that one. And then let's try in the second equation. 2 times 1 plus 3 times 1 is less than 9. Okay, well, isn't that 2 plus 3? So isn't that 5 is less than 9? So do we agree that it is a true statement for both of those? So this one works. All right, take the next point, which is -2, 6, and we're going to plug it in. So this does take a minute. -2 minus 6 times 6 is greater than -48. Okay, well, that's -38. Is it? Did I plug in the right number? Yeah, 2 and 6. Anybody agree with me? So it works in the first one. Now let's check the second. So I'm doing the first equation in red, and I'm doing the second equation in green. So when I go to plug it in here, it's 2 times -2 plus 3 times what? 6? Okay, that's -4 and 18, which is, 14 is not less than 9, is it? Okay, so it doesn't work. I'm just going to put, I don't know, I'm just going to cross it all off. So check mark if it works. I'm throwing it out if it doesn't work. All right, then we just keep going. So I think I'm going to put the points in another color. What's the next point? 9, 2? I'm going to have to make some room here. All right, so we're just going to run through each of these points and see if they work. I don't need you to write a book, but you need to show something. Which one? The first? Oh, good catch. Thank you. All right. Is that better? So we would have 9 minus 6 times -2. Well, that's 9 plus 12. So I'm getting 21. Do we agree? I think it works. Okay, and then plug in the 9 to the next one and see if that's true. So 18 minus 6, I'm getting 12 is less than, 12 is not less than 9. So I'm going to throw this one out. It does not work. All right, so go ahead and keep testing them. All right, so we went ahead and finished this up, but I did pause the video. So each one was checked. So -8, -3 both made true statements. It works. We got a true statement and a false statement. If the first statement was false, I don't have to check anymore. Both of these were true, so there we go. So the ones that were true stand out. They're 1, 1, -8, -3, and 4, -7. Okay, last part here. Now we're going to reverse it. I have given you a graph, and you are going to give me the inequalities. So we want everything to be in the form y equals mx plus b. And what two things do you need for y equals mx plus b? You need m and you need b. Now, what's nice about these graphs is that they're made that I don't have to do the algebra because they have a nice y-intercept, and I can see the y-intercepts. But if not, I could always pull 2 points from a line and go back to my y minus y1 equals m times x minus x1. Remember my point slope form? So I could always algebraically write the equation, but we can do it with finding, and I'm just going to do this one. I'm going to highlight this in red here. I'm going to find the slope, which I'm going to start at this point and go up 1, 2, 3, 4, and over 2. Well, what's 4 over 2? Positive 2. And what's the y-intercept of this line? It hits the y-axis at 0. So the equation of that line is y equals, but I'm going to hold off, 2x plus 0. Now, I held off because it's not equals. This line would be shaded going down, wouldn't it? So if the shading is coming this way, where my ruler is, it'd be less than. And it's solid, so be less than or equal to. So I'm going to write that down here, simplest form, y is less than or equal to 2x. That's the one inequality. All right, go to this other diagonal. The slope of this one should be positive or negative? It should be a negative slope. Okay, so the two things I need are m and b. Okay, so I'm going to go down 1, 2, 3, 4, and over 2. Well, what's negative 4 over 2? Negative 2, and the y-intercept is up here at positive 4. So my inequality is y compared to negative 2x plus 4. Okay, if you look at this one, it'd be shading everything coming below this line. So again, y is less than or equal to. Nothing here. Oh, I'm missing my x. Nothing here to simplify, so I'm just going to bring it down. Y is less than or equal to negative 2x plus 4. All right, we've got one more inequality, and it's a horizontal line. What is the slope of this horizontal line? Slope is 0, and what's the y-intercept? Negative 2, right? Okay, so my inequality would be y is compared to 0x minus 2. Now this one is shaded on the upper half. So that would be y is greater than. Can it be equal to? No. I'm going to bring this down and clean it up. 0x is the same as saying 0, so y is greater than or equal to negative 2. Oh, what did I write? Oh, just greater. You're right. Okay, better? There is my system. All right, you try the next one, and then we'll go over it. All right, on this equation, the slope, what are you guys finding? I think it's 1, up 1 over 1, right? And the y-intercept is 2. So my equation is y compared to 1x plus 2. And it's shading going down, so y is less than or equal to. Are we good with that? You don't have to rewrite it. I'm just trying to put them all in one spot. But I wanted to show what I was doing by the line. All right, here's this one. Uh-oh. Why am I saying uh-oh? Well, I can do that. I'm going to go down 1, 2, 3, 4. And I'm going to go over 1. So I'm fine with the slope of negative 1, but guys, I can't find the y-intercept.
Well, no, we got to do it.
We're going to have to do it. Okay, now maybe my slope's off. Hold on, let me look here. Down 1, 2, 3, 4 over 1. Yeah, I'm fine with that slope. Okay, so the y-intercept, that's an issue. We're going to have to find the y-intercept, and so I need to pick a point. So I'm going to use, I think I'm going to use the point 1, 3 on this line. And I'm using it just because it's an easy point, it's a nice point, and it's very clear it's 1, 3. So do you remember your point slope form? Y minus y equals your slope times x minus 1. Do you remember your point slope form? So this is going to take a minute, but we can do it. I would have my y minus 1 equals negative 4x plus 4. Add 3, y equals negative 4x plus 7. Now, I know that some of you would have just extended this up and estimated where it was, but I thought this would be a good review of that. Now, I can't use an equal sign, right? So it's going to be y is what compared to negative 4x plus 7? Well, this red line shades where? Coming down. So y is less than or equal to. Okay, we've got one more line to do, and we have the same issue. I can see the y-intercept, but I actually don't know what it is, so we're going to have to deal with that. All right, first things first, it's dashed, so we'll have to remember that. What is the slope of this line? Down 2, right 3. So m equals negative 2 over 3. but the y-intercept, we don't know. Okay, pick a point on this line. What would you like to use? -1, 1 or 2, -1?
Let's do -1, 1.
Okay, so x is -1, y is +1. All right, I'm going to do my work over here. Here we go. Y minus 1 equals my slope times x minus a -1, which is going to become positive. Distribute your -2/3, and we get y minus 1 equals -2/3 x minus 2/3. And then I'm going to add 1. Now, you want to get your little calculators out? You can. But if I have minus 2/3 and I add 1, doesn't that leave me a positive 1/3? Maybe. So add 1, I get a positive 1/3. I can't use my equal sign, so let's rewrite it. Y compared to -2/3 x plus 1/3. This dashed line is shading going up, so it'd be just greater than. Okay. So if there's 3 lines, I should have 3 inequalities. If I can read the line and I can clearly see a y-intercept, then I am good to just pull the slope and the y-intercept. But if the y-intercept's off the graph or questionable, we're not going to estimate. We're going to use our skills in point slope form.